In this video, we're going to look at an example of finding the volume of a solid using spherical coordinates. So we're being asked to find the volume of the solid that's inside the sphere x squared plus y squared plus z squared equals 4, above the xy plane, and below the cone z equals square root of x squared plus y squared. Alright, so the red surface here is our sphere that we're talking about. The blue surface is the cone, and we're above the gray plane, which is the xy plane here. So we're looking at this reddish circular region here. We notice that no matter where we are, if we think about starting at the origin and going out to the sphere, I always hit the sphere. I never hit the cone. So our rho values are always going to go from 0 to 2. I never hit the cone piece here. I always just hit the sphere as I go out. All right, this cone, we can check that the angle that the cone makes, if you think about any line going straight down the cone towards the origin, the angle that makes with the positive z-axis is pi over 4, and then the angle that the xy plane makes with the positive z-axis is pi over 2. So to be inside this piece of the sphere, our theta has to run from pi over 4 to pi over 2. Finally, our solid goes completely around in the xy plane. Right? If we start at the positive x-axis and go counterclockwise, I end up back to the positive x-axis again. So our theta is going between 0 and 2 pi. All right, so we now have our solid described in spherical coordinates. Remember, if we want to compute the volume, we can just do a triple integral of dv. That will give us our volume of the solid E, where we're doing the triple integral over E. So we replace the differential with rho squared sine phi d rho d theta d phi. Rho's go from 0 to 2, thetas go from 0 to 2 pi, phi's go from pi over 4 to pi over 2. Our integrand is factorable into a product of single variable functions, function of rho, function of theta, function of phi, and our limits of integration are all constants here, so I can break this iterated integral up as a product of 3 integrals. The middle integral is easy, that's just 2 pi. Antiderivative for rho squared is 1/3 rho cubed. Evaluated from 0 to 2 gives us 8/3. Antiderivative of sine of phi is negative cosine phi. Evaluated at both endpoints and subtract, we'll get root 2 over 2. So putting everything together, we'll get 8 pi root 2 over 3.